Hello friends, welcome to this video. In this video, we are going to build the TensorFlow input data pipeline for a semantic segmentation task using the tf.data API. So let's start the code. So first of all, we will import the libraries which we require. First is OS. So the operating system library which we are going to use to join the paths. Next is a numpy. Import numpy as np. And the third is a CV2 which we are going to use to read the image and the mask. Next is the globe. So we are going to use this to list all the images inside a folder, not specifically the images and the mask for the data set, as we are using it for semantic segmentation. And next, the most important, that is TensorFlow. Now let's write the main function. Okay, first we are going to specify the path for the dataset, and for the dataset I'm using this CVC612 dataset, which is a polyp segmentation dataset. Let me show you some of the images. So these are some of the images, and I've already built a detailed video about the polyp segmentation using the unit. Click on the I button to watch the video, or you can check out the link in the description. So you can see the mask. It's a binary segmentation. The masks are either black or white. So we're going to use this data set. Let's specify the path CVC612. So first of all, we're going to load the data set, that is the images and the mask. So we'll write a function tf.load data, and its parameter would be path. So images would be like, first of all, we join the path using the os.path.join function. First the path, and inside path we have images, and like this we're going to specify for the path for the mask, os.path.join path and the masks. Make sure that you write the correct spelling. And now we're going to use the globe function to get all the images and the mask inside these folders. And here after image we're going to write slash and a star. So star basically refers all the data, all the files inside it. So inside them there's only images and masks. So here, from here we have to return the images and the masks. So we have loaded the data successfully. Let's check it out. Images less masks, masks, load data. Okay, specifying the path. Now let's see the length of the list for the images and the mask. If they both are same, this means that we have loaded data successfully. Okay, let's run this code and check. Okay, let me just write one more thing, a print statement, a blank print statement. Okay, so you can see the images are 612 and the masks are also 612. Now let's move back to the code. Now we will write two functions. First is going to read the image and second is going to read the mask. So let's write the function read image. It's going to take the path for the image, return us a 3-dimensional image. And for reading the image, we're going to use the OpenCV function imRead, which take the path and the cv2.imRead color. So this text cv2.imRead underscore color specify that we're going to read it as a RGB image. So after reading, we're going to resize it, because for any semantic segmentation task all the images need to be of the fixed shape. So let's resize it, cv2.resize, giving it the x and the size. So here we specify it as 256 by 256. So all our images are going to be the size 256 by 256. Next we are going to normalize the image pixels by dividing them with 255, that is the maximum pixel value. Now all the pixel value are in the range of 0 and 1. After that we're going to specify its data type, that is float 32. Now we're going to return this numpy array x. We're going to write the same function for reading the mask. specifying the path. So what we can do, we can copy everything from the first function because it's basically same except something. Here we're going to change it from imRead_color to grayscale. Now we are reading it as a grayscale image, and after that we resize it to the same size, that is 256 by 256, and then we normalize the image pixels and convert its data type to a numpy 32. So let's check this out, these two functions, if they are working correctly or not. So x is equals to read image, okay, the path is images, and let's take first value, that index 0. So y is equals to read mask, like this, first value from with the index and the mask. And let's check the shape. From the shape we can get an idea if everything is fine or not. So now you can see the shape. The shape of the image is 256 by 256 by 3, and 3 here indicates that it's an RGB image, and for the mask the shape is 256 by 256, so that it's indicate that it's a grayscale image. But if you remember any semantic segmentation tag, the output would be such like the height by width by the number of channels. So here we didn't have any channels, so what we do is we expand the dimension on the last axis using the numpy function. Let's do it. So x is equals to np dot, the function is expand dims, give it x, and the axis is last, or you can specify 2. Let's specify -1. Now again we are going to run the code and check. So now you can see the shape for the mask has changed to 256 by 256 by 1. Both the functions are working successfully. So let's now move on to the main code, that is the tf.data API. First of all, we are going to write a function tf.dataset. It's going to take the list of images path. After that is going to take the list of mask path and the batch size. So by default the batch size we are going to set it to 8. Let's create a variable named dataset, tf.data.dataset, and from tensor slices. Okay, so this function from tensor slices is going to take the x and the y, that is the list of images and mask path. After that we are going to shuffle the dataset, and we need to specify a buffer size, and we're going to set it to 1000. After that we're going to use the map function, and here in the map function we need to specify a name of the function which is going to take the image path and the mask path and process them and return an array, the proper format. So we haven't written this function, but we write its name here. And after completing this function, we need to move on to this function, that's pre-process function. Okay, so let's define an empty function, pre-process, which is going to take an image path and a mask path. So these x and y are not the list, they are just individual path. After that, after the map, we're going to set the batch size with the batch function. And next we are going to use the prefetch function to load some batches in advance, like if we specify 2, so 2 batches are going to be fetched in advance. Now I'm going to return the dataset. So that's all for this tf.dataset. Now I'm going to move to the pre-process dataset, pre-process function. Again I'm going to write a function which is going to take the individual image and mask path and return. So let me just do one thing, print x comma y here, so you can see what we get inside this f function. So as we are going to use a Python function for reading an image and a mask, and these function cannot be directly used in TensorFlow, so we need to convert them in an appropriate form so that TensorFlow can use them, and for that we're going to use the tf.numpy function. It takes 3 parameters. First is the name of the function, that is f. Second, we need to provide the input the function f takes, x and y. And third is the data type for the output of the function f. So it's going to give you the image and the mask in an array format. So it's going to be So their data type is float32. So we can specify at tf.float32. Same with next float32. Okay. So what it return is images and mask. So now we need to set the shape for this image and the mask, and you already know what the shape is. The terminal we can see that is 256 by 256 by 3, and for the mask it's 256 by 256 by 1. So let's write it 256 by 256 by 3. Now it's time for the mask. Set shape, and here we will specify 256 by 256 by 1. Okay. Now we are going to return these image and the mask. So let's call this function here. So dataset is equals to tf underscore dataset. Okay. Then images and the masks. Okay. Now it will return as the image and mask as a batch in the batch. So x and y in dataset. So x and y here are the batches of image and mask. So we need to print their shape. For now we won't get the shape, we would get an error because I haven't written the function completely, but there's a purpose behind it. So I want to show you what these x and y are. That's why I've written whole thing, but haven't written the function f completely. It's just 2-3 lines, not much more than that. Let's run this and check. So you can see we have an error, but in between errors you can see these lines. These are just the image path and their respective mask path. Okay, so we don't have the correct images and mask. Okay, so what we can do here is simply sort them here in the data load function. So that's why it is necessary to first check these things before working on these. If I just directly work them without seeing, then it would be a problem because the images and mask don't have the correct names. So let's see, I have sorted down the names. So now you can see the image path is find underscore 321 and the mask is also find underscore 321. You can see the same name for the image and same name for the mask. Okay, so now we can continue our work. So you can see the B written in front of them. So we need to decode these and give them to a function, that is read image and the read mask. So let's decode these. X is equals to x dot decode. Okay, y is equals to y dot decode. Okay, now they are decoded. Let's print them again. Now I'll show you what they look after being decoded. You can see now we have simple clear path, the image path and the mask path. Let's continue. So let me call the read image function here with x as its variable parameter, y is equals to read mask and give mask. Now we are going to return these x and y. This function is complete. That's it. Nothing more. Now here you can see this function, this line will work correctly without any error. We will get the shape of the image and the mask batches. So you can see the shape. So we have a shape of 8 by 256 by 256 by 3, and for the mask we have same 8 by 256 by 256 by 1. So 8 indicates the batch size, which we have specified by default as here. So what we can do, we can change the batch size to like 128, just increasing it, and maybe 128 won't work in real life because I don't know what hardware you have, but my computer is really just GTX 1060. It won't support that much high batch size. Okay, so you can see we have an error. Okay, I have written it an incorrect place. I need not to specify, just need to write it here. Okay, let's run it again. So now you can see with shape with the batch size 128. So you can see first we have a batch size of 128, then again 128, then again 128, then again, but in the last we have 100. This is due to that only 100 images are remaining in the last. So a batch size of 100 images are only formed. But the main thing here is to check is that if the image is batch size of 100, then the mask should also have a batch size of 100. That's the main thing here. Now what we do, we just check these masks and images if they are correct or not by just saving them in a proper image format. So let's do it. X. So if we have taken the image at mask at the index 0. Now we all know that these are in the numpy for these are in the tensor format. They are in the tensor, not numpy. So you can see the x and the y, they are just tensors. You can see tf.tensor. So we need to convert them to numpy, and also you can see their values between 0 and 1, and for the mask there's 0 and I believe it's 0. We haven't seen 1, but we'll see. So we can convert them to numpy easily just by calling numpy in front of these. So now they are converted into numpy. Now we can save them. Let's print this shape first. Let's run this code again and see this shape. So you can see this shape from this is 256 by 256 by 3, and for the mask it is 256 by 256 by 1. So for the image it is correct, but for the mask we have to reduce this, squeeze this one and just convert it back to 256 by 256, that is its original form. So we can do this simply just by calling another function from numpy, squeeze. And we squeeze y on the axis -1. Okay. Oh, I have written 1 here, minus. Okay, now it's correct. Now again we're going to check the shape if I've done it correctly. Now you can see the shape for the mask is 256 by 256. So now we can save them through the OpenCV. So cv2.im right. First we need to spare the path, that is image.png, and the x. Okay. Second, same function, I am right. This time I'm going to save the mask .png and y. And also, I just forgot, as you know that these values are between 0 and 1, so you need to convert them in a standard format that you can see. So we're going to multiply back them with 255, as we have divided them by 255 in our read image and read mask function. You can see here they are divided by, mask is divided by 255, and in this read image function we have divided it by 255. So we're going to multiply these both with 255. Now we're going to save them. Let's run this function, and I hope there would not be any error. So you can see no error is there. So the code is run successfully. So you can see the image and the mask. So through this we can make sure, we can check that everything is fine, no problem is there, because the images what we have done is load the data set, build the complete tf.data pipeline, and again save those arrays back into an image format. And here we can see that both these images are fine, they look like original, just that their shape is 256 by 256, just that changes it. So that's how you build a complete pipeline for the semantic segmentation task. You can use this code for any binary segmentation dataset, would work fine. And that's it for this video, and I hope I was able to give you some new knowledge, and if I did, then grab the subscribe button and give me a thumbs up, and follow me on Instagram to get the update about my channel. Till then, have a good day.